Hello, friends. Thank you very, very much for coming all this way in the dark and the gray and the wet to hang out with me this morning. I will do my very, very best to not waste your time, like I have been doing for the last 45 minutes while we watch YouTube videos. But there's not only folks that are here in the room, but also folks that are watching us online. My name is Scott Hanselman, and I work on the Azure and ASP.NET teams. And this is what I'm calling the unkeynote, because they can't keep me from saying that. Plus, it's like 8:30, so none of the actual people that work at Microsoft are awake right now, much less at this talk, so that's pretty cool. We've got a bunch of really cool ASP.NET and Azure content at the conference, and a lot of stuff I want you to think about after this talk. This is kind of the kickoff. So we've got HTML5, and we've got SignalR, and we've got web forms, and we've got MVC, and we've got Entity Framework 6. There's a bunch of great talks. So make sure you look at all the different talks from our team and think about the things that I'm going to show you as being like a hub talk that's going to launch you off into these other things. And then at the very last talk of the conference, John Galloway, along with me as Code Monkey, are going to show you some kind of bleeding edge stuff. So we kind of bookended these talks. But what I want to talk to you guys about is this idea of what I think is happening on the cloud side and on the browser side, and that I think it will change the way that we're writing software. So this is kind of an experiment and a bit of a philosophical discussion I want to have with you guys. So welcome to Microsoft. But it's open source now, so it's way better. We've got these two things, the cloud and the browser. And in the cloud, you can have an infinite number of virtual machines. But I think that we have one more virtual machine that we can use. And that's going to be the kind of the postulate of this discussion. But let's talk about the cloud first and what it means. And I mean not necessarily the Azure cloud, but the general idea of the cloud. There's this quote from this fellow Thomas Watson. And we can't prove that he said this. But let's just say that he did, because that's what we do with quotes. I also don't know what he looks like, but I did have this really old book, so that's the guy. I mean, while we're making up quotes we can't substantiate, let's just make up pictures of guys we can't substantiate. So this fellow, I think it was IBM, like 1940, 50, 60, somewhere in there. I wasn't born, so it doesn't really matter. I'm joking. He said there's a world market for at most 5 computers. What did he mean by that? He literally meant that there's a market for 5, 6 computers on the planet. Well, this is a picture of the Azure data center. And this is the kind of computer that he was talking about. He was talking about these giant computers that fill up a room, that do complicated computing that we can't see. We talk to a terminal, and the computer exists far, far, far away. And is that Scott Goo right there? And now we are in this situation where we have pocket supercomputers with quad-core processors in our back pockets that we complain about. I know that I am carrying my car around as a backup battery for my phone. It exists as nothing more than a carbon-based generator by which I recharge my phone as many as 3 times a day. I actually recently went to the AT&T store over at the Commons there, and they've got this amazing battery. It's 16,000 milliamp hours. It's like this big. And I just keep it in my back pocket and just have the battery around, because that's how hard these things are working. So we're at this situation now where there are 5 computers. There's our cloud and the Amazon cloud and the this cloud and the that cloud, and they exist. This has happened already. So the cloud is infinite computing that we can tap into. And this is so significant because it completely changes how we create computers, how we move computers from place to place, and how we have a relationship with those computers. Now, when you go to school, you do operating systems class, they usually give you a list of the characteristics of what describe an operating system. And they say, all right, well, an operating system has memory management, and it has storage and these things, and it has networking. And if you can check off all these boxes, and you can not check off graphics if we're talking about a headless machine, then that describes an operating system. Okay? Then you take those machines, you virtualize them, and you throw them into your data center. then suddenly you're moving machines around from the cloud to your data center, from your cloud to somebody else's cloud, other people's data centers. I remember the very first time that I saw like VMware, just years and years and years ago. But even before that, when I ran Desk View for the very first time, and then I ran Windows in a window, I mean, I just thought that was the greatest thing ever. OS/2, things began to virtualize, and then I got more power, I got more flexibility in what I was able to do. And now, fast forward to today, and you can run Linux in Azure, which is just nuts. It's insane. Why do we allow that? Somebody should tell someone. I can go to the command line now, and I can type Azure. This is a really great tool, my friends. This is a great little command line tool. You can get this just by typing npm install Azure. And you know it's a great tool because it has ASCII art. And we've got this RESTful API to talk to Azure, which means I can talk to it from anything. And what's great about it is that all of the different tools that talk to Azure do it through the public API. Such a crazy idea, it just might work. I can go and type things like Azure site list, and that's going to go make a JSON call and find out what are the different sites that are on Azure. So those are the sites that I'm currently running on Azure. But I can also go and type Azure VM create fancy pants VM, and then put in an image name. That's the name of an Ubuntu image that's already sitting up there. And I could say Scott and fancy password. I don't know. There's a good password. No one will know what that password is because, of course, you can't see that. I'm sure it'll be secret for about an hour. And I can go and make this image. And it's going to go and look up that existing 30 gig image, and it's creating a service to support it. And in a moment, that's going to appear in Azure. I've just spun up a complete machine. I'm going to go up into the portal here and log in and see what's going on. And I didn't have to install any operating system disks or download any ISOs. I just did it. What's interesting about that, not is just I can make a virtual machine in one line. It's the for loop. It's the implied for loop. OK, one VM. Awesome. Great demo. Cool. All right, let's do 1,000 of those. There was some interesting stuff. I think it was the New York Times that had like they needed to have like an intern digitize all of their stuff and turn it into PDFs or something. They had hundreds of years, terabytes of files from all of the issues of the New York Times. So then they spun up some virtual machines, did a giant OCR job, shut it down, and it cost like $300, and the intern charged it to the company card. Right? That's the power of the cloud, and that changes the way that you solve problems because it abstracts you away from something that was really non-trivial before. So there's my virtual machine in the cloud. And I could then, SSH into that or remote or whatever I want to do. I can fire those up whenever I feel like it. So then if you up-level that one more, where we're not just making virtual machines, we're making virtual stuff. And this is where things started to click for me with the cloud. Because I was talking to Scott Gu, late at night on the phone, just kind of breathing and listening to each other breathe, because that's it's kind of how we roll, You hang up. No, you hang up. I'll count to 3. OK. 1, 2, 3. Scott, you didn't hang up. I'm cool with it. I'm cool with Anders like that, too, except it's more like, hi, stop calling here. Scott said that websites in Azure were built on top of virtual machines, and mobile services that we saw yesterday at the keynote are built on top of websites. And websites are actually built on top of cloud services. And what this means is that even the guys that wrote mobile services aren't thinking about things in terms of virtual machines. They've up-leveled that. So they can go and say, well, I want a website. No, I want 2 websites. No, I want 3 websites. And it just happens. That's so powerful. And I don't think that we're used to doing this because we've been in software for 10, 15 years, right? We've been thinking about this for a while. But imagine if you just jumped in now. What if you became a web programmer right now? What if you missed the tribulations, right? Maybe you did a little CompuServe, you know what Telnet is, and then you put your head down for 20 years. Right, you missed out on HTML and tables and Netscape 4 and all that stuff, And then you woke up now, and it was like, yeah, this is how you code. You need some virtual, you need infinite power. Yeah, infinite power, that's cool, just write a for loop. Awesome. How would that change how you write software? I was talking to one of the chief cloud architects at Netflix, and he was telling how his cloud provider was switching from spinning Rust hard drives to SSDs. And there was this kid in the audience who was, really hip, let's just say, and very smart. And he said to the guy, and the gentleman was extremely distinguished and accomplished, and he was like, we're moving all of our things over to SSD, and it's going to be awesome, performance. And the kid was like, because that's how I'm making him sound. So what about the trim command on these SSDs that's going to keep it from writing? There's going to be some problem because SSDs have a tendency to fail. What about with the mean time before failure? And I'm thinking to myself, that is a really great question, because I don't know any of those acronyms, and I am a phony, and I shouldn't be here. And why? What is a trim command? I need to know what that is. And I'm furiously Googling with Bing to figure out what that is. And he says, okay, so then I'm thinking, what's the question? He's probably thought about this. He's probably thought about SSD failure, right? Because he's the chief architect of something, right? He should know that. So you know what the guy says? That's not my problem. Well, whose problem is it? He says, I don't know. It's not my problem. I'm renting them. He's not even thinking about that. You know what he is thinking about, though? Number of I/O operations per second. All he knows is that he went from paying $1 an hour to paying $3 an hour, and his I/O per second went from some number of thousands to some number of tens of thousands. And he says, 3 times more money, 100 times more power, awesome. If they wear out, I don't care. I'll get another one. Click. Hey, I just spun up another data center in Europe. Awesome. Now I'm going to take a lunch now. Like that's like, I just assume that's what like life in the chief architect's seat at like a major company is. I need you to sign this, sir. Hang on. Click. All right, the data center in Europe is set up. I'm going to Bennigan's. He doesn't care about that stuff. That is so powerful. Websites on Azure right now, you could put in SignalR, right? We just announced SignalR as an official part of ASP.NET. You can go and say, add new item. SignalR is right there. It's a real thing. But if you put it on websites right now, even though we support .NET 4.5, we don't support WebSockets. Tragedy, right? When are you going to support WebSockets? Why you no show new stuff, Scott Goo? But when WebSockets show up, am I going to have to upgrade my operating system? No. I'll just wake up one day and they'll be there. And then SignalR will fall forward, and they'll light up one day. Scott Goo said that when they put websites on Server 2012, it'll just work. And because you're using SignalR, it'll just work. And think about that from a business person's perspective. That's so cool. The other thing that's great about the cloud is that the cloud doesn't care about language choice. It really doesn't. A good cloud does not care about language choice. .NET, Node, Java, PHP, whatever you want to write, you should be able to write in your cloud. And the cloud should be open. I'm really happy that the cloud that we've got will let you run anything and in any hybrid that you want, because the reality is an open system is a really good system. Except for that really creepy lady. I can go and do this. Let's fire up. Yep. Let's go like this some. Let's bring up Visual Studio. New project. We'll make a 4.5 application. Hit OK. So that's MVC application 2. Let's see where that's going to show up. Is that there? 8:44 a.m. That looks like nowish, doesn't it? All right. I can say Azure site create awesome site. I don't know, 1138 -- get. I love command line stuff. So it's going to go and not only create a site, but it's going to run git init locally there, and it's going to set up a remote for me so that I can publish this site, the site that I just made. So it's going to take that site, and now I can say git add, put all that stuff in git commit, git push Azure master, go up here into websites. What did I call it? Awesome site? Awesome site. 1138. It's awesome. There it is. Deployments. So it set up a Git repo. Whoops, it was actually too fast for me. Azure site browse awesome site 1138, because really, really awesome programmers launch the web browser from the command line. I just decided that that was the case just now. So that happened too fast for me. You see this where it says deployment history? Let's say that I go in here to our view. Let's say this here. Modify this template. And let's say that something bad happens and maybe I have a bad commit. Okay? In case anyone in the back missed that. Okay? Okay, so when I have the browser here, I'm going to push that change up into the cloud. I forgot to set up all my passwords and keys and stuff. There we go. It's building that in the cloud. You watch that deployment there. I don't have to do anything. It just happened. Okay? I go over here, hit F5. That's there. But then I'm like, oh, man, we totally have to fire that guy. That was totally not OK to do that. Then I push the oh shoot button, redeploy back. Then I wait, worried that it won't work. And then it works. That up-leveling is so significant. It's so significant. Think about the amount of work it takes right now at your company to get a virtual machine. Just brainstorming. I don't know you. But if it involves a fax machine to get a new piece of software installed, right? If there is a 2-week wait and a signature, I don't care if the signature is scanned and in a PDF. If it involves a signature to go and get a database or virtual machine, then someone is forgetting that programmers exist to help the business and not to be slowed down. Everything on Azure is open source, which also makes me very happy, because you can go up and get all of this stuff and look at it. You can even go and look at the command line itself and see how we did it. And then if you don't like those command lines, you can just call that API by yourself. Doesn't matter, which is also extremely cool. And you've probably already heard that ASP.NET, MVC, Razor, and Web API are all open source. If you haven't heard that, now you just did. This is pretty cool because you can actually go and see the check-in mails from the team. This isn't where we check in internally and then we push that stuff over. Occasionally we give you a zip file every 3 months. You can actually read the check-in mails. And this is an interesting thing I got into with a guy on Twitter last night, which is like, well, we can either surprise you by telling you nothing for a year and then go surprise, or you can read our check-in mails and then you have no surprises. It's a little bit of a challenge there. But I really like an open cloud and I like an open stack. And it makes me happy that these things are available to us. And even if you want to run IronPython, that's OK. No judgment. No, I'm just playing. The IronPython tools that came out a couple days ago were bananas. You should check them out. So I was showing some of this stuff to a guy who had worked at Intel for I don't know, however long Intel's been around. But the guy had been programming for 30 or 40 years. But he had a Rocket Mail account. To give you an idea, he was a super technical person, kernel drivers and stuff, but really not a web person. And now he's finding out that this scale exists. And he can write these amazing tools, but they're usually at the command line. How would you scale something like that? This is a prototype, a brainstorming. This does not exist yet. But there's a guy internally who's thinking about this. let's say that you write some application that public static void main does something at the command line. And in this case, it's just writing a text file out. But maybe it's processing OCR, optical character recognition, or maybe it's resizing images. Okay? This is the kind of thing that this gentleman who's been coding for 40 years would write. But then he says, well, I want this on the web. I want to do this n times. But he's been out of touch for a little while. So the gentleman who's working on this, Mike, has postulated that what if I could take that, and you see where it says text reader and text writer? That describes an input and an output. What if that came from the cloud and was the cloud? So he could just take that program as it is, because he knows how to write programs, and he knows how to write them at the command line. He just wants to do it bigger. So then he copies it up into the web, and he adds a couple of attributes. You need to tell me, by the way, if you want this or not, so then we can tell Mike to keep working on it. So he says blob input, and it says, well, I'm going to take anything that matches this file, and then I'm going to output it into this file here, and then as anything new shows up into that blob input holding folder there, I'm going to run that. Think about how empowering that is as an abstraction layer for the gentleman who has been coding for 40 years but missed out on the web. And then he woke up and he has infinite scale. Now he can write something that works on a megabyte and then throw it up in the cloud, and now it works on a petabyte. And that's extremely cool. That would be like this batch processing in the cloud, but simple batch. So if you could write a console app, you could potentially write something big like this. So if that's something that you're interested in, let me know on Twitter or email me, and we'll kind of keep people up to date on whether or not you think that's interesting. But I think that that's the kind of up-leveling above virtual machines that is really, really powerful. So you can have an infinite number of virtual machines, and, well, you can have an infinite number, but I think you can have one more virtual machine. Which virtual machine is that? I propose that the browser itself is a virtual machine. So if you have an operating system that has these characteristics, operating systems have memory management, operating systems have networking, et cetera, et cetera. There was a time when you would walk up to a computer and you would think that was the computer. And it was really talking to that computer, which was where the real work happened. And then you would log in if you wanted to do something like, uh-oh. There we go. And you would log in to some terminal, and you would see it over there, but it was really happening over there, right? And then we kept building and building and building. And these machines on the left were really stupid. They're terminals. They don't do any actual work. And then there was a web page. This is the web page. This is the start of the internet. That's the very first web page. There actually is a first page. That's the one at CERN that Tim Berners-Lee put up. Funny story, actually. The gentleman who works on ASP.NET Web API also was one of the co-authors of the HTTP spec and was Tim Berners-Lee's intern. So my buddy who worked with me on the keynote demo was talking to this guy. He doesn't know who he is, right? And then he's arguing with it, and then he leaves. And then he wrote HTTP. And what? Yeah, you don't even say anything to him. You just, yes, sir, no, sir, would you like a Coke? It's completely changed my relationship with the guy. What do you say? You know what I mean? Do you argue like the details of the HTTP spec with the guy? You know, hey, yes, sir. That's good job on the web. Nice job building the underlayment of the internet. That's a great pair of shoes you have there, sir. Can I get you anything? It's kind of cool, though, to work with someone like that, on the team. So that's the page. But Tim Berners-Lee expected that these pages would be interlinked pages of documentation for scientists. Didn't think about interactivity. It was documents that linked to documents. It was hypermedia. And then this happened. And then this happened. And then this happened. And things got really interesting because suddenly something that you could describe as an operating system with memory management and storage APIs and threading and all those things showed up inside the browser. And we all remember when this happened. I remember the very first time that I discovered this. Actually, here's another funny story. So I was at Toyota to get my car fixed, to get the oil changed or whatever, because programmers don't change oil. And the guy says, hang on, we've got a new system. I'm just getting used to this new system. So he says, he fires up Windows, fires up IE, fires up some ActiveX shim, fires up Java, fires up a jar file that represents a telnet that then VT100s into a mainframe. And you know what he tells me? This is so much better than it was. You remember the first time that you found a Java applet? So you can navigate. You're clicking around the web. It's documents and documents. I'm buffering. Java's starting! Hard drive smacking around. What does that light flashing right there in your laptop mean? Well, honey, that means Java's starting. There's a light for that? Yeah, there is actually a light. There is actually a light for that. And then the internet consisted only of two kinds of things: web pages and physics demos. And then Java was only really used to show GIFs that had a shimmery reflection underneath. Right? That's what Java was good for. But this really started making you wonder, why are we doing this? Because this is this kind of document browser thing, and this is a really powerful virtual machine. That's amazing. We've got this virtual machine, but things marched forward. And then this happened. And it wasn't even called JavaScript. I think they just called it that. It was live script, remember? And they called it JavaScript because Java is fun to say. And it's certainly more fun than ECMAScript. I've asked a number of JavaScript programmers if they know what ECMAScript is, and they think it's something else. I don't have the heart to tell them. So JavaScript happened, and what did you think when you saw JavaScript? You were like, OK, alert. Cool, now I can do alert. That's going to be really convenient later. And then people started to say, well, maybe I can do more than alert, right? Maybe I could do something else. And then you started seeing things like this. Yeah. So here in JavaScript, that's the circle of patience. This is a JavaScript emulator, a Commodore 64 emulator, written entirely in JavaScript. It's real, because you want to play Galaga. Now, it only requires an i7 with 8 gigs of RAM and 8 processors to simulate this 30-year-old machine with 64K. No, that's actually better than that. It's actually really fast. It's pretty amazing, and it's like a real thing. People started pushing JavaScript into potentially inappropriate places. But that is a far cry from alert. That's JavaScript's growing pains. That's JavaScript learning if it can really do something. How far can you do that? OK, I've got an i7, and I've got a fast machine. I've got a great multi-threaded JIT in my JavaScript-enabled browser. But what else could I do? Well, this is this is loading. Let's see if our internet connection is good. This has to download quite a bit of stuff. When all else fails, reboot. That means Control F5. Let me see if I can bring up multiple virtual machines. I'm an equal opportunity browser. Where's Opera? There we go. That is an entire x86 emulator written entirely in JavaScript. It's not a fake. How do you know if it's not a fake? I think that's a fake. I think they cheated. Oh, I can select it. It must be real. Because that's what you do on the internet. If you see something and you go, oh, right-click, oh, it's Flash. You cheated. You cheated. That's not real. How did you do that amazing chart and graph and spinning animation? Oh, Flash, cheater. You know you've thought it before. Now I'm compiling Hello World in C on a JavaScript emulator of a Pentium processor inside of a browser. That's nuts. The fact that I can do that, if that doesn't convince you that JavaScript is an extremely powerful virtual machine is you're dead inside. Because if you can't make declarative statements when you're on stage at a conference, when can you make declarative statements? You guys see this? Yeah, it's nuts. I want to talk about crazy. Check this out. Contre Jour was the #1 iPad game in 2011. This is that game in HTML. Check this out. It's got credits. I don't know why that impresses me. It's got credits. If your JavaScript has like credits, then it must be really awesome. Let me think of other examples of JavaScript that has credits. Does that have credits? Where's my example? These are all my examples. You never know when I might need any of these things. This one guy, I'll show you this in a second. So check this out. Look at this. Whoop. It has touch enabled too, if I had a touch enabled thing. Look at this. See this guy here? Woo! He's laughing at me in JavaScript. You can see I'm very easily impressed. That's real. That's not cheating. And the guy that wrote it's still laughing and things are moving around. It's crazy. The gentleman that wrote that didn't believe it was possible and was saying that I'm not going to let you release it if it's not like pixel perfect. I did a podcast with these guys that you should check out. It's pretty ridiculous. So JavaScript starts happening. And it's happening fast. It's happening faster than anyone really thought it would happen. So suddenly, I can go to this gentleman who missed out on the last 20, 30 years of the web, and I can say, hey, listen, there's a new operating system out there. It doesn't really have a name yet. We'll call it HTML5. And it's got garbage collection, and it's got 2D and 3D, and it's got storage and databases and everything. And what's this person going to think? OK, cool. I've written operating systems for years. I can totally do that. Think about how empowering that is. Forget about all the work that you did before in the last 20 years. And think about the possibilities that you have not only an infinite number of virtual machines on the server, but one additional virtual machine that you can really, really utilize here on the client. What does that mean to your applications? And we'll talk a little bit more about that in a moment. You can actually replace JavaScript with Microsoft Excel. And that is also true. So Atwood's law does indicate that any application will be written in JavaScript. Let's talk about this. You have two operating systems on the portable device you have. You have your Windows Phone or your Android or your iOS. And then you also have JavaScript. That's the second operating system that ships with your machine. And as a web guy myself, as an angle brackets and curly braces person, I think that that's a really powerful opportunity. And I'm disappointed when I hear about things like this. This gentleman said that that was a problem. Betting on HTML5 was a mistake. Should have bet on native. It wasn't ready. I think that the best world is one that you have a foot in each. And that's why I think it's really exciting to be a curly braces programmer right now. Because I feel extremely empowered on the server, picking any language that I want, to do whatever I want to do. C#'s my language of choice, but you can pick whatever makes you happy. And then on the client side, I can pick JavaScript. And I get a lot done. So I disagree with that. I think that one of our great philosophers said this: the avalanche has already started. It is too late for the pebbles to vote. Who said that? Actually, a guy said Gandhi before, but it was in fact Kosh from Babylon 5. Huge nerd right there. Let's give him a hand for getting that reference. I tip my hat to you, sir. You may have my Coke Zero later. I ran through this with a buddy of mine. He was like, is that Kierkegaard? No. Gandhi? No. Dick Van Patten? No. It's Kosh, Babylon 5. A lot of good quotes from Babylon 5. So HTML, CSS, JavaScript, then if that comprises an operating system, it comprises more than just an operating system. It comprises a virtual machine that we as web developers aren't exploiting. We as web developers aren't exploiting. Now, once upon a time, there was a time when if you wanted to get a job in software, you needed to know one thing: tables. And the interview usually consisted of, do you know tables? I do know tables. Boom, junior engineer. But do you know row span? Senior engineer. You know call span? You're running the company. That was I was a table. Woo, I could make some tables. Woo-wee. Even now, I could nest some tables with the best of them. My buddy Pete's got a t-shirt that says, screw it, I use a table. That's awesome. I could do like a whole hour just on tables because I love me some tables. But that was really complicated. So now they keep saying HTML, HTML, HTML5, but HTML is even simpler than ever. You can do applications with just one div. This is kind of cool. And again, I'm an equal opportunity browser, so I'm picking different things for different examples. Check this one out. This is a website called CSS Deck. And this is a picture of an iPhone. Okay, that's a lovely, lovely iPhone there. The only difference is that this iPhone is actually created entirely with CSS. See how he's typing in the corner there? You want to learn a lot about CSS? Watch it be done. Watch this guy do it. And what he does is as he's typing, it's actually updating on the side there. So you can see, as he creates it, he's trying different things. Trying to get the color right. And he's actually describing it to you in the corner there. But notice in the upper left-hand corner, how much HTML is there? Apparently that's HTML5 now. I just write a div, and that's basically all you need to do. This ends up looking pixel perfect by the end. And the neat part about this, that there is not a single PNG or graphic there. This is how the young people use Paint today. They paint with 123 lines of markup. But it definitely illustrates the power of what can be done and the fact that it's more than just HTML right now that you need to think about. HTML is just the structure. CSS is the color and the style. And JavaScript is that engine. And you see this kind of pervasive as we make AJAX calls. You've been doing this already. You're making AJAX calls, returning JSON into your applications. If you're a Silverlight programmer, you're returning JSON. You saw us returning JSON into a Windows 8 application. Services, services, services. Looks like angle brackets. Didn't happen. Now it's curly braces. That's cool. Don't like SOAP? That's fine. We'll just search and replace. We'll make it all curly braces. It'll be all right. But what's interesting about this, though, is that all of those techniques assumes a powerful machine on the client. I had a really great conversation with Herb Sutter, who is on the Visual C++ team, and he was saying that something like 50% of PCs that are sold have a hardware-accelerated graphics card, like a dedicated GPU. Think about that. Remember the days of the 386? Did you get a DX or an SX? SX? Oh, you can't run Excel now. You'll never be able to do math. 2 plus 2 is beyond you now. Always get a coprocessor, my friend. Have we thought about coprocessors since? No. But now we have things like CUDA and NVIDIA, and you can compile C++ and run it on the CPU or the dedicated GPU. That's an amazing thing. But what do we make these machines do? What do we make these machines do? We make them wait for angle brackets from the server. We make them wait. We treat these machines with 8 gigs of RAM and 8 processors like they're VT100 terminals. We spin up infinite number of VMs on the server to sort our lists of 100 items. Yeah, that better hurt. You should feel that one because you're doing that. You're like, oh, yeah, I pretty much did that. Sent that list all the way back to the Asian data center, sorted those 100 items, and then shot them right back across the world and output them again. This is actually valid Objective-C, but in my mind, I'm imagining a JavaScript programmer not nailing it. So I thought that was a cool thing. That's what I thought the very first time I saw that. Have you ever heard this quote? JavaScript is the assembly language of the web. Who said that?
You did.
That's right, I said it. I love you guys. You're so fun. Actually, not just me. Everyone else said that. I didn't actually say it. I tried to take credit for it. A lot of people disagreed. JavaScript is the assembly language of the web. That's heresy. Well, someone was wrong on the internet that day. So I emailed the guy who invented it. And I said, JavaScript's the assembly language of the web. Back me up. And that's Brendan Fraser, actually. That's Brendan Ike. But I like that picture of Brendan Fraser. Brendan Ike said that JavaScript is the x86 of the web. But he can't claim it's real. As with all good quotes, everybody gets to take credit for them. He said it's the x86 of the web. Things compile to it. And that, I think, is where it gets really, really interesting, because we talked about multiple language choices on the cloud. I can pick any language I want, and I can scale it up. That's awesome. On the client, I have the one language. I have JavaScript. And I should know JavaScript, and we should all learn it. Every programmer should know JavaScript. You should still use the languages that make you happy, but this is becoming a very ubiquitous language because it's the most accessible virtual machine. It's the one that everyone has. It's the VM that doesn't require plugins. This is CoffeeScript, though. This is not JavaScript. This is how a Ruby person would write JavaScript if they wanted to make JavaScript feel and look and act like idiomatic Ruby. So this is their domain-specific language. And this transpiles. It kind of translates, transforms, and compiles into some JavaScript. And what's great about this is that you can think about CoffeeScript and then magic happens. And that's totally awesome. And that's the first example of someone really compiling something into JavaScript. There's also things like GWT and Script Sharp and all these different kinds of techniques where someone is saying that I don't really like JavaScript. It's no fun. I want something that's more fun. Another example is TypeScript that Anders is going to talk about. And Anders has got this little annotation there, constructor greeting string. And notice that it even gets stripped out. It doesn't even exist on the right-hand side because it's just an annotation. I'll talk a little bit more about this because I think we need to expect more from our tools. This can cause C# and .NET programmers a little bit of pain because they feel like, well, am I supposed to write JavaScript everywhere? What does this mean? And then now we've got this static language optional typing creeping into our dynamic language. And then it becomes this whole East Coast, West Coast, Biggie, Tupac kind of static versus dynamic language fight. And that's just totally not cool. So I think that there are ways to do both. And I think we should look at those ways. Let's do this. I've got a couple of files I want to bring in to show you friends. This is using some of Mads Christensen's Web Essentials. Web Essentials 2012 is something you should download, and you should check out Mads' talk later today. Mads has this Web Essentials playground where he puts crazy things that the web team might want to do into it, and then as we find them awesome, we pull them out of the playground, and then we put them into the product itself. And you can see these things today. And one of the things that he did is he took the TypeScript stuff that Anders and friends did and did this. Here's a TypeScript file. I'm actually going to drag it into my app and open it up. And rather than just using the default TypeScript stuff, what he ended up doing was making a split-screen editor. So I've got TypeScript on the left here, and then as I make changes over here, they appear on the right. And then as I write my TypeScript, my JavaScript pops out right there. Yeah, it's pretty cool. And as I hover over these things, I get all that great IntelliSense and typing information that one would expect from a typed language. So now we're starting to expect a little bit more from our tools. We've got a layer on top of this. We could go and do something like a refactoring. Which is something that would be extremely hard to do in JavaScript. It usually involves a search and replace. And when you search and replace in JavaScript, it always ends in blood. And an extra couple of these. So that's TypeScript, but what else kind of things could we do with this? Well, here's a good example. Web API, which is kind of my fun new thing. Web API is great because it's part of the larger one ASP.NET strategy that we've got. And Web API was actually originally WCF Web API. It's now ASP.NET Web API. And you can use this in web forms, in MVC, in web pages, anywhere you want. You don't have to. This is not an MVC thing. It's not relegated just to MVC. Here is a web API controller called person. That's going to return some people and their respective ages. They're not here, right? And notice right here in this post, this is an API that loves HTTP. Just because that's named post, that's what will happen when we post. Just by virtue of the fact that get is named get, that's what will happen when we hit get. Look at person. That's a statically typed thing. We can all agree on that, right? Person is a person. It's statically typed. And if I go look at person, it's like a real thing. Here's person. That is a C# class. Static typing. OK? And it's going to come from the body. So I've got that marked as from body, and I've got a breakpoint. So I'm going to run that. And then what I've got down here is a batch file. And this batch file is just going to post a person to that endpoint. Just posting some JSON. So I'm going to be clicking that batch file. That's why I'm showing it to you. So I post that. Comes over here. Let's look at value. So dynamic JavaScript, JSON, deserialized into strongly typed C#. We've done this kind of stuff before. We've seen SOAP deserialize into objects. Sometimes this can be extremely frustrating because the objects don't get shaped right. And then you say, well, here's another example of static dynamic type mismatch, blah, blah, blah. It's over, right? We need to pick one. We can't have both static and dynamic. That's bad. Imagine a slider bar, though, if you will, between totally static and totally dynamic and interpreted. And imagine if you could put that bar back and forth. This is on the static side. Let's change person, and let's use JToken. That's saying, this is some JavaScript. I don't know what's in it. It's kind of a bucket. Think of this as kind of like a DOM. Remember DOMs in XML? Think of this as like a DOM for JavaScript. I'm going to go and post that. Here it is. Now I've got this bucket of stuff, and I could link my way through it. I could add and remove JavaScript from this, and it wouldn't break because the deserialization wouldn't break. So I've moved the slider bar slightly over. Okay? This would be kind of like not statically typed and not completely dynamic. Now let's change JToken, and let's move the slider bar all the way over to dynamic. And this is where people start arguing that, like, what's happening to C#? I love my language. But there are people who write C# applications, and they only use dynamic. And Rob Connery knows who he is. But what's cool about dynamic is that when I ask Anders during our late night phone calls what this is, and he says, well, that's statically typed as dynamic. And then my brain explodes. But we can bind to that. I'm going to run that and post my person. Hopefully I didn't post it too fast. And there it is. So that slider bar moves backwards and forwards. And that's what's great about this, is that I can pick how much I want to buy into my tooling. I can pick how much I want to expect from my tooling, how much I want to expect from my language. And that's why I think it's a really great time to be a .NET developer right now. I don't want to have too many layers, though. I think that sometimes people look at this and they think it's really complicated and they feel overwhelmed. I know I feel overwhelmed. I don't know HTML5 and JavaScript. It's too much to know. I get frustrated because I'm not a front-end web developer, and my design experience consists of going to Template Forest or whatever and downloading a template for $16 and then taking credit for it. When people get overwhelmed by this, I remind them that this is just a library of APIs. This new operating system, they can just pick the ones they want. If you just want to learn geolocation, You can call that API, and you can get the user's location, and you can get a polyfill that will allow you to even access that on older browsers. You don't have to know all this stuff. But I would encourage you not to put too many layers on top of these things, because you will hide some of the complexity. No one writes JavaScript anymore. They write jQuery. It's nice to still know a little bit of JavaScript. And this is funny, though, because when we were younger, they'd say, all right, we're going to teach you C, young man, but before we teach you C, we're going to make you suffer in assembler. Now, OK, that sucked, didn't it? Yeah, well, it did suck. OK, well, now you know C. You never have to look at assembler again. Now, we're going to teach you C++, son, but before we do that, we're going to teach you C, and we're going to make you suffer. And then they slowly move you all the way up. If you jump in at jQuery, though, you're going to miss out on some really, really cool stuff that's going on. Who said that? Me. Also. Everyone said that. Because if you build too many layers, you have this view in your mind of what you're going to build with those layers, and it never turns out the way that you want it to turn out. and you don't know who to blame. And you feel... No, I'm teasing. I love those guys. Totally teasing. Have you guys considered using the very, very exciting Vanilla.js JavaScript library? This is an amazing library that I would encourage you to check out. It's a very fast, lightweight, cross-platform library. You can actually go in here and pick the features that you want. I want Ajax. I want DOM traversal. I need a math library. I'm going to need arrays. And it'll actually calculate for you dynamically the size of that uncompressed. It gets a little bigger when you gzip it. And what's great about Vanilla.js is that this is your debug path to your Vanilla.js file. And then at production, you just change it. Best part about Vanilla.js is it's highly performant. This is a little example of the 12 million operations per second you can do using Vanilla.js library and jQuery. The point here is not to disparage these libraries in any way. The point is to know what's happening underneath. Just know it, understand it, so then when you up-level, you know what you paid for. You know what happened. I still love jQuery, and I use it all the time. But remember what's happening underneath. Remember that these layers exist. Remember that you're writing to the operating system of the web. So every time that you buy into a layer of abstraction, that you know what you're buying into. I also think that we need to expect more from our tools. Even though these specs are often changing and a lot of things are happening, I can expect a lot more. And I think that Mads' examples are really great. Not just his TypeScript example, but let me show you a couple more. And he'll show you a lot more in his talk. Take a look at this. This is a CSS3 file. And I can get a little color swatch here that shows me what that color would look like. I can also pop down a thing that will show me the colors that exist in this file. And I can go like this. I can even pick this tiny sword of wounding here. I'm not quite sure what that is. It looks like it's from Zelda. I know that. So I can pick the Zelda sword and then pick one of the many colorful choices that Visual Studio has made available to me. But his stuff also, without changing the spec, expect more from your tools. I can hover over fonts. Yes, nice, yes? I can get those. I can even do things like grabbing images, drag them in. Notice that I can hover over these, by the way, see which image I want. Drop it in here. I can see which browsers support that feature. Yeah. I can hover over the image within the CSS. I can embed that as a base64 bunch of characters so that I prevent an HTTP request. And I can even do things like border radius tab, 20px, enter. Oops. There you go. 20px, 25, 26. I could say this one's 20, but Mozilla is going to be 25. So he's broken away from the rest of the pack. And now he's back. And now he's back on board with the rest of us. That's all stuff that can be done in the tooling. And I point that out because there's some really, really amazing things happening in tooling right now. I know that everyone loves things like Sublime Text, but IntelliSense and autocomplete are different things, and I think it's important for us to remember that. So the cloud is offering you this massive scale and elasticity. You can make VMs like this. You can make websites like that. Take advantage of this. It is so powerful. It changes the way you develop, except people forget about the extra virtual machine. They forget about the one that is deceptively powerful, that is rich, that is integrated and requires no plugin, that has accelerated graphics, the one that exists on the user's machine already. So you have unlimited virtual machines. You can write in any language. Your user has this powerful VM. You write in JavaScript or target it. This is the great part. You don't have to write JavaScript. You can target it. But that user's virtual machine is so important. It's part of the cloud. So how can we put that machine to work? I made the example earlier about sorting stuff and how silly I think that is, that we sort stuff. Take a look at this. This is one of the greatest JavaScript libraries there is. It's called D3. And this is an example of a 5 megabyte data set, which is largish. I realize that. And I'm not proposing that we start downloading 5 meg JSON files. But I am proposing that you start thinking about it, because you could send that 100 items that you want to sort across the wire, or in this case, 250,000 airline flights, all in a list here, that can then be sorted and filtered by a number of different dimensions. And I could even link to just show me mornings, weekdays, weekends, all in JavaScript. And where's the work happening? On my hardware-accelerated multiprocessor machine with a 3D graphics card. We don't use those things. And it doesn't require anything except the will to do it. So your cloud doesn't need to work so hard. This is one of the greatest things ever. This is the co-occurrence diagram of the characters in Les Mis, and when they appear together on stage, organized as a matrix. Is that not the nerdiest thing you have ever seen in your entire life? Seriously, I want to meet this guy, because that is epic. All of it, HTML, using D3. That's bananas. This guy, Mike Bostock, is nuts. Makes all these amazing diagrams. D3, yeah, look at that, it's just nuts. This is all JavaScript. And these are these node link diagrams, all done in JavaScript, where the work is happening on your machine, on whatever browser that you've got. Get that machine doing some work. The cloud is great, but don't forget the extra VM that you've got. Don't forget that extra virtual machine. Remind yourselves that you're not obsolete. You are very, very powerful. You guys know this stuff. You know C#, you know VB, you're learning JavaScript, or you know JavaScript. You've got an immense amount of power available to you. Libraries and an infinite virtual machine in the sky, and a super powerful one in your pocket. There's a new operating system that's shipping every day, and you just need to press F5 to reboot it. So go out there and know the cloud, program the browser. Get to work. I would encourage you to check out the other talks we've got that are going to go deep, deep into this stuff. We've got Mads talking about HTML5, and Damien talking about SignalR. We've got Entity Framework folks. We've got a bunch of ASP.NET talks over the next 2 days. Please have a great time at Build, write good code, and tweet us if you've got any ideas